Hello there, welcome to this video 10-3, and we are going to solve some right triangles. That's our objective today. Find all side and angle measures of a right triangle. That's what it means to solve a right triangle. Just find everything you need to know about the triangle. There's 3 sides, 3 angles. We're going to find the missing information. All right, that's our task today. All right, really quickly, just as a prior knowledge, we want to go ahead and find B, side B to the nearest tenth. So notice I have 2 sides. I'm missing 1. So what theorem do we use that involves all sides of a triangle? Pythagorean theorem. Okay, so this is a squared plus b squared is equal to c squared. Just a reminder, again, side C across from angle C is the hypotenuse. So this is 10.2 squared. Side B, that's what I want to find out, b squared. And then A, side A, that's across from A, this is 8.1 squared. Okay, so if I want to find b squared, I can go ahead and subtract 8.1 squared from each side. So b squared is 10.2 quantity squared minus 8.1 squared. And then b is the square root of all that, 10.2 squared minus 8.1 squared. Okay, and let's see what this is approximately. They tell us to round to the nearest tenth. So that's going to be, we want the square root of 10.2 quantity squared minus 8.1 quantity squared, and that gives us 6.2. So this is approximately 6.2. Okay, next prior knowledge. Now we want to find the measurement of angle B. Okay, and angle B is right here. And I'm told that angle A is 53 degrees. Okay, well, I know that all angles in a triangle, all angles in a triangle add up to 180 degrees. It's called the triangle sum theorem. They all add up to 80. And especially for right triangles have a angle that is 90 degrees. So this means that the other 2 must add up to 90. So there's 2 acute angles, measures less than 90. So how can I use this information? Well, if angle A, measurement of angle B, if angle A is 53, I can go ahead and I can subtract that from 90. And then that's going to give me the measurement of angle B. This angle and this angle will add up to 90. Always, 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 always for right triangles. Okay, so we can go ahead and do this, and it looks like we get 37 degrees. So the measurement of angle B is 37 degrees. Okay, so we're going to use those ideas today to help us solve some right triangles. Just a reminder on our trig ratios, again right here, right next to my head, we have SOHCAHTOA. So sines opposite over hypotenuse, cosines adjacent over hypotenuse, and tangent is opposite over adjacent. If you're trying to find an angle, you're going to use the inverse function of those ratios, and that will help you solve for the angles. Now, here are some steps or some things to keep in mind when you're solving right triangles. Again, it means to solve, find all the sides, all of the angles. And in order to solve a right triangle, you need to know at least 2 side lengths or 1 side length and an acute angle measure. And based upon the information, your kind of approach to the problem is going to change. You may have to use the Pythagorean theorem. You may have to use inverse trig ratios to help you find angle measures. You may have to use trig ratios to help you find sides. And you may have to use the triangle sum theorem. That's another way to help you find angle measures, okay? And the key idea here is that you want to use exact values. Whenever possible, use exact. So we're going to try to use whatever information's given to us, okay? All right, so let's go ahead and look at our first example. They say solve the right triangle, round side lengths to the nearest tenth, and angles to the nearest degree. So different places for rounding, just a heads up. Okay, so what do I need to go ahead and find? So I need all sides. So it looks like here, okay, B. I don't know what B is. I have to find it. I don't have any information on angle A. Measurement of angle A, don't know what it is. And then same with the measurement of angle B. Don't know what it is. So those are the three things that we need to find. Again, I have side C. Here's side C given to me. And then here's side A. That's given to me. And then I know that angle C is a right angle. It's 90 degrees. Okay, so I got to find three things. So what am I going to go ahead and do first? Well, I'm going to list side B. I'm going to find side B first. So side B. Well, I have two sides already. So can't I say 2.7 squared plus B squared is equal to 3.1 squared? I'm using the Pythagorean theorem to help me find that missing side. Okay, so subtracting 2.7 over to the other side, 2.7 squared, we get B squared is equal to 3.1 squared minus 2.7 squared, and thus B is equal to 3.1 squared minus 2.7 squared, square root of that. So I'm just taking the square root of both sides. Okay, and of course we're going to use our calculator for this. So let me go ahead and adjust this. This was the square root of 3.1 squared minus 2.7 squared, 2.7 squared. Okay, and it looks like we get approximately 1.5. We're rounding to the nearest tenth for sides. So B is approximately 1.5, and we do want to include units. So 1.5 centimeters. All right, so I just used Pythagorean theorem, and I found that information, approximately 1.5. Okay. So now, next, let's go ahead and look at the measurement of angle A. Measurement of angle A, which is here. Okay, and if I want to find this angle, I want to use a trig function, and specifically an inverse trig function, because I want to solve for an angle, and I'm given two sides, here and here. So remember, you want to use exact side values. I don't really want to use B, because that's approximate, it's not exact. I'm given this information, I know it's reliable, so I'm going to use these values. So what sides are they? Well, opposite of A is given, as well as the hypotenuse. So that is a trig function sine. So SOHCAHTOA. And again, if you ever forget, you can write SOHCAHTOA down on your paper. So opposite and hypotenuse is sine. Okay, so sine of A is equal to 2.7 over 3.1. And I want to solve for A, so I'm going to use the inverse. All right, let's pull up the calculator. Okay, so sine inverse 2.7 divided by 3.1. Okay, and we get 60.57, so that's going to be rounded to the nearest degree is what these problems want us to do, so that'd be 61 degrees. 61 degrees. So approximately 61 degrees. Okay, I'll add that over here. And if you want, you could go ahead, you could do the same approach to find angle B now. So here's angle B. I'm given now adjacent and hypotenuse for angle B. So I know I could go ahead and I could say, okay, adjacent and hypotenuse, that's cosine. So cosine of B is equal to 2.7 over 3.1. So B is cosine inverse of those two values. You could do that, and that would be exact, 100%. But I do have something that's kind of an easier idea. Doesn't A and B add up to 90, right? They do. They do. 61 plus B, whatever it is, this is going to add up to 90 degrees. Those two angles add up to 90. So what I can do is I can solve for B just by taking away 61 from 90. And we get B is 29 degrees. 29. And that's quicker. I like using the triangle sum theorem best. Okay? And ta-da! I have found the missing side and the two missing angles. And there we go. And if you don't believe me on the triangle sum theorem, if I just change this, let's change this to cosine inverse. Boom. 29 degrees. You get the same thing. Okay? Alright, so there is that example. Next example. We want to solve the right triangle. Again, round the side lengths to the nearest tenth. Sides are to the nearest tenth. Angles to the nearest degree. So again, for this example, I am given two sides. Okay, so I know my two sides, and I'm missing F, side F. Got to find F. I'm missing angle D. Measurement of angle D, and E, measurement of angle E. So our approach here is going to be exactly the same. I'm going to go ahead and I'm going to find the first side F using the Pythagorean theorem. So 5.3 squared plus 8.8 squared is going to equal F squared. And taking a square root of each side, we'll get F. So let's go ahead and calculate all that. So the square root of 5.3 squared. Why did it do 2.5? 5.3 squared plus 8.8. Hold on, something's weird's going on. 5.3 squared plus, there we go. Okay, and we get 10.3. 10.3. Okay, so F is approximately 10.3. All right, now I want to go ahead and find, let's just do D. So D, what trig function, or what sides do we have? Remember, label. Label your sides. Label the sides. So for D, again, I'm going to do this in pencil because it's going to switch if it was angle E. D, I'm given opposite and adjacent. So that's tangent. Okay, so tangent of D is equal to 8.8 over 5.3. And then using the inverse functions, tan inverse of 8.8 over 5.3, that will give us D. So we can plug that into our calculator. Okay, oh, I don't want tangent, I want tan inverse. Tan inverse of 8.8 divided by 5.3, that is 58.9, that's going to be 59 degrees. 59 degrees. So approximately 59 degrees. Okay, And then step 3, now that I know that angle, that it's 59 degrees, I can just go ahead and the measurement of angle E is going to be 90 minus D, which is 59. Okay, and that gives us 31 degrees. Okay, 31 degrees. All right, and we have solved the right triangle. That's it. All right, here is a practice problem. Please go ahead, pause this video, give this one a go. All right, hopefully you went ahead and solved this. For side P, you're going to need to use the Pythagorean theorem. P squared plus 8 squared is equal to 18 squared. To solve for angle Q, that is given opposite and hypotenuse, so you're going to have sine. So sine inverse of 8 over 18. And then for the measurement of angle P, I would just take 90 and subtract whatever Q is. So that's your general approach. Here is the solution. And you can see those values here. All right, the next example is the same type of problem, but this time they're being tricky. They don't give us an image. They're going to give it to us in words, and so this can be difficult sometimes, but there's a trick here that I'll show you. So they say solve the right triangle PQR, so those are the points on the triangle, with line segment PQ perpendicular to line segment PR. And that's what this symbol right here means. It means perpendicular. And if two lines are perpendicular, they have a 90-degree angle. So 90-degree angle. And that's what they're telling us. And why this is important is because of the 2 points that they use to describe this, PQ and PR. So you'll notice P is the intersection of both of them. So I'm going to go ahead, step 1 for this, I'm going to just draw the triangle. And that point that's the same, that's your intersection point. So I'll say here, okay, this is P. And then I'll call this Q, and this R. You could flip-flop Q and R, it doesn't matter. But P needs to be the right angle. So P is our right angle. Okay, then they're going to give us some information. They say R is 47 millimeters. Well, the side across from angle R is little r. So here's R. This is 47 millimeters. They say the measurement of angle Q is 52 degrees. Okay, so here's Q, and this is 52 degrees. And then they want us to solve. Round side lengths to the nearest tenth, angles to the nearest degree. Okay, so what I don't have is I don't have the measurement of angle R. I need that. I don't have side Q. I need to find what Q is. That would be here. Here's Q. And then I don't have P. I'm missing P. And that is here. Here's little p. Little p. Okay. So let's go ahead. Let's solve these. And I listed these in order because the first thing I want to do is I want to find angle R. Now, why do I want to find the measurement of angle R? Well, I am given angle Q, which is 52 degrees. So if I subtract 52, again, this is the measurement of angle Q, I can get the measurement of angle R, which gives us 38 degrees. Okay, so this is 38. 38 degrees. Okay, and I'll place that here. 38 Okay, so now I want to find P or Q. It doesn't really matter which one you want to find, but I'll go with Q just because I listed it that way. So number 3. Okay, so if I want to find Q, I'm given this angle here. So I'm given 52, and Q is opposite, and R is adjacent. So again, I'm labeling it. I'm using the angle that's 52. It's given to me. So opposite over adjacent, that's tangent. So tangent of 52 is equal to Q over 47. Okay? Now, if I want to go ahead and solve, I'll multiply both sides by 47. 47. And we get Q is equal to 45. 47 tangent of 52. Okay, and we'll plug this in with our calculator. All right, 47 times tangent of 52. And we get 60.2 if we're rounding to the nearest tenth. 60.2. Okay, so Q is 60.2. And this is millimeters. Make sure to include units. Okay, and then lastly, I need to go ahead and I need to solve for P. So let me erase my side labeling here. So Q, well, I guess my side labeling is still valid. So if I want to solve for P, again, I'll use angle 52 because that's given. Use what's given. So 52. The side next to it here is adjacent, and then P is hypotenuse. I want to solve for the hypotenuse. So adjacent and hypotenuse, that is the cosine function. So cosine of 52 is equal to adjacent over hypotenuse. Call it P. Okay, so if I want to solve this, I'll multiply both sides by P. And we get P times cosine 52 is equal to 47. And then we'll divide both sides by cosine of 52. And so P is equal to 47 over cosine 52. Okay, so let's plug this into our calculator. So 47 divided by cosine of 52. And we get 76.3. 76, approximately 76.3. Okay. All right. This one was a little bit different. Remember, we had to draw the triangle. That posed its own issues. Again, I could draw the triangle, and I knew that P was the right angle point because it's in both line segments. I placed the information. Because I was given an angle, I could easily find the other angle just by subtracting that from 90. So that gave us 38. So I found my angle, and then I just used our trig functions to find Q and P using the given information. So you'll notice both of my equations here, the tan of 52 and cosine of 52, I used 52 in both, and I used the side angle 47. All right, here is a practice problem. Please pause the video, try this one. I'm going to go ahead and give you the triangle first, and then I'll show the answers. So pause the video, give this one a go. Okay, hopefully you drew a triangle, and it doesn't have to be amazing. I mean, mine's pretty amazing. Look at that triangle. And the side that has a sharing point is A. So this point right here, this is going to be A, and then it doesn't matter which one you label, but I'll just do B and C like that, or it could be flipped, okay? All right, so they give you some information. They tell you AC is 29, so here's 29, and angle B is 34 degrees. So there's our given information. Please pause the video, solve this triangle if you have not already. Go for it. All right, here is the solution. Notice they flipped their triangle, so again, this is even different than mine. They placed B down here. Okay, but here are the values. Angle C is 56 degrees. You get that from subtracting the given 34 from 90, so you get 56. And then using the angle 34 and the given side that's 29, we can find the other two sides here. All right, here's another practice problem, this time with the triangle given. So please pause the video and solve this right triangle. All right, hopefully you solved it. Here's the solution. So you should get these values. Okay, and then the last practice problem. So here's another one. Please pause the video and solve for this triangle. Okay, here are the solutions. If you don't have units, that's fine. You could just put 15 here. Okay. All right, so last closure. How do we know when we have to use inverse trig functions when solving a right triangle? What do we use the inverse trig function for? Go ahead and write a response, and I'll show you the answer here in a second. All right, here is the response. You use the inverse trig function when you're finding the measure of an angle, an acute angle, and you have to have two sides. So that's when we use inverse trig. All right, hopefully you enjoyed this video. Hopefully you learned something, specifically how to solve right triangles. Give it a thumbs up, like it, subscribe for more awesome math content, and I'll catch you next time. Peace out.